Quick thank you to our sponsor, who without them, we wouldn't really have this conference. All our sponsors are great. In particular, in this case, we have Wiz, who are a silver ranked sponsor. So thank you, Wiz. And without further ado, I pass it over to Ben.
Hello, thank you so much for the introduction. Hi, my name is Ben Haußner. I work in an internal red team here in Germany, and I specialize in the cloud and in CI/CD, and that's what I'm going to speak about today. So the title of the talk is Continuous Integration, Continuous Deception, Trying My Luck as a Malicious Maintainer. And I have done that for the last year, and I want to share the results of my research with you guys. Don't worry, everything that I talk about today is going to be in a repository. You get the link at the end of the talk, and you find the slides there. But the most important thing is you find all the releases. We're going to tamper with releases today. You find everything in there. You can diff them. You see all the detailed attack steps and everything. Supply chain attacks are a problem. I think more or less everybody in this room has heard about last week's breach of Chalk and Debug in the NPM space. And last month, we had a breach with the company NX, also in the NPM space. And half a year ago, there was the infamous incident of TJ Action changed file that Rami is going to talk about tomorrow, which I'm really looking forward to because he has way more detail into that. So with that out of the way, what is a consumer's perspective on a supply chain? I'm going to get everybody on board real quick. So on the right, we have the consumer. This is us. And this is what we consume, like our releases that we download from an Artifactory like NPM or GitHub releases or PyPy. And all of that other stuff we don't really care about normally. Like I have seen companies that started caring about that, and they are introducing SAS test on the application code of releases that are being published, but they don't really care about the pipelines. And so that's what we're going to look into. So what is the perspective of a maintainer? We switch into the maintainer perspective now. This is us, we are the producer, and we have control. We have control over the source. This is where we keep our source code for the application as well as for all the pipelines. We have the build stage. That's where our pipelines are going to run. We have third-party or first-party dependencies, so we kind of have control over that. Then we have the distribution, again, where we put our releases, and we have the consumer, that is our user. And I will talk everything in the context of GitHub today. So why don't we do a regular release together, and later we're going to start meddling with that release. So this release is version 0, benchmark release, nothing bad is going on here. Source stage, we have two files. First file is original.txt. It's just a text file. Normally, this would be source code, of course, that we're going to tamper with. Here we're just tampering with a txt file, and you can imagine later we're going to change the contents of that. And then we have our release YAML. It's a little bit much, so I'm going to go more in detail here. So when we have a release, we name the thing, create release from tag, and so every time someone pushes a tag that starts with V for semantic versioning, we're going to run this pipeline. This pipeline will start a job named create release. It runs on Ubuntu latest. Normally that means that this is a GitHub hosted runner of the type Ubuntu latest, and everything runs there. GitHub is responsible for the infrastructure and for the images, and we cannot really influence them. And we have permissions here because the principle that is running in that chain is the GitHub bot. And so this GitHub bot needs the permission to write into our repository to actually drop the release. And then we have two main steps. First is the checkout step. We are using the third-party actions checkout to do basically a fancy git checkout. So we have our file original.txt locally in our runner. And then we're going to do a create release using the GH-CLI tool and just push our file original.txt into our release for our repository for our ref name, which is v0 in this case. And that's it. So very straightforward. When we look at the build run here, we see it was successful. We've seen a green check mark, and we see our two build steps, checkout, create, release. Everything is good there. And we look at the distribution, and we see one asset. It's original.txt. I also opened the file content up for you, so you can see it's an original file. We see the SHA-SUM that automatically gets generated. We see GitHub Action bot did the release, and also we see the commit hash that this release has been started from. So they are really combined together. So in theory, you should be able to click on this commit hash and see exactly the source code that led to this release. Again, this also could fire in the direction of NPM. PyPy or any other extension store, we're just going to stick with GitHub today to make it easier for us. So now let's change our perspective. I'm going to put up my black hat, basically. Let's say I got phished, and now I'm a malicious maintainer. Or this morning I woke up and I was really mad at everybody in the room, and so I decided, hey, I'm going to be a malicious maintainer. There are thousands of reasons, and again, in my repository, just saying this README is about 80 pages if you print it out, so it's really in-depth. I also have examples for the different reasons this could happen, of course. What's important for this talk is we do not hack into repositories, so don't understand the wrong, please. We are already this malicious maintainer, and our one goal, and only one goal, is we want to poison the release, and we want to do that without changing the source code of the application, because we think that's too noisy, because it's open source and people would be able to see that potentially. So that's out of the question. We do not care about what our release does in the end. If it totally misbehaves and calls out to weird IP addresses, that's not a problem. It's really just about the poisoning part. And one last disclaimer, it's a shell game, so no CVEs are involved. There is something going on with me and GitHub at the moment because I've maybe found something cool. We'll see, but the process is still running. So everything we are doing here is we are taking regular features and abuse them for our own profit, basically. I'm going to show you 3 attacks. The first is meddling with a mutable release. We're going to touch the source stage and the distribution stage. Before we do that, we look at the status, metadata of the release, and you can see this release has been published at and updated at the same timestamp, so probably hasn't been touched. And also, the asset has been uploaded from the bot account of the GitHub Action. So that's exactly what we expected. We can actually go in and manually tamper with that release. That's not really hacking, that's clicking on a button in the GUI. I was kind of like, what, this really works when I first learned about this, and it's really interesting. Whenever I talk to people, they are kind of 50-50. One half of the room is like, yeah, obviously, that's how it's supposed to work, and the other half is like, what? that can't be. So I would love a very quick raise of hands. Who thinks yeah, of course, this is how it's supposed to be? Okay, and the other half, who is kind of like, what? You can meddle with these? Woohoo! Okay, good. I was kind of worried, everybody would are you? No. Okay, perfect. Okay, so let's go in there and do that. But manually doing that would lead to this. We see published ad and updated ad is minutes apart. I can click faster than that, I promise, but this is a very big indicator that something is going on. Also, the uploader is a user of the name Offensive Actions. It's my GitHub handle, so that's bad. What are we going to do? We're going to open up another branch in our repository and push a temper release YAML. And this temper release just continuously runs, and as soon as the release version 1 gets, the not malicious release gets released, this thing goes ahead, this workflow, deletes the original TXT file and puts another one in. So it's very straightforward. And the thing is, this is the metadata you'd be looking at as a defender. Published and updated ad, there is 1 second difference. If you get lucky, you don't even see it because you don't see the milliseconds here. And the uploader is still the GitHub Action spot because we abused the workflow for that. So that's a little bit, as I said, it's a shell game. It's like a little hat trick. And our original TXT has been tampered with, as you can see. So let's look at the indicators of compromise here. How would someone see that this is going on? There are no changes to the source code. We didn't do anything to the application source code. We just tagged the version 0, we checked out version 0, tagged the version 1, and re-released it again. So that's not it. Here we see 2 different APIs. We see the Events API and the Releases API. The Events API publishes events for GitHub repositories, and for a release event, it only does that on the first publish, not when you later touch the release. So it releases all the file hashes here. Spoiler alert, it also sometimes works differently. Check my repository. And when you look at the Releases API, you always see the latest status. So in this case here, we see it's different digests. That's pretty good for us. The problem is the Events API is not real-time. It differs anywhere between 30 seconds and up to 6 hours. And for one of my repositories, for whatever reason, I don't even have that at all. I just have no events in there. So how do you protect against that? Enable release immutability. GitHub is really pushing for immutability, and so that's a feature that it's in public beta right now. Ask the people who maintain the stuff that you consume to maybe just switch that on. That would already help quite a bit. How you detect this? Again, I'm not going to say that over and over. Find it in my repository. You'll find hunting leads en masse. That's really nice, but to make it harder, we are now going to switch release immutability on for ourselves, because otherwise that's kind of boring. Now we're going to typo squat our own supply chain. It's the second attack. Again, we're going to touch the source or the definition of our pipeline. And so we also touch our pipeline and a dependency. Squint your eyes. Who would spot that? Who would spot the problem? It's really small, so I'm going to make it a little bit bigger. Someone raise their hands. See a second hand, third hand, perfect, thank you. So yeah, this is Acklon's checkout, it's not Action's checkout. That's a really cheesy game here, I know. But Acklon's was free, and so I took it. And so what I did is I just went ahead and I copied the source code of Action's checkout, like the 3 vital files I need, put them into my own repository, and tagged it with version 5 and released it. Also, I added these 2 lines in line 18.9.5 and 18.9.6, so good luck finding that. That's where the meddling is happening. And yeah, so we see we have an immutable release that we still tampered with. How can that be? Yeah, because it switched to being immutable like after the workflow run, of course. I didn't attack the immutability per se, I attacked the workflow run, so I squeezed in, basically. So yeah, it still works. Pretty nice, good result for us. What are the indicators of compromise if we want to go hunt for that? Of course, you definitely will see that. Acklons, I mean, everybody in the room probably, when they spot this, say, yeah, that's not good, like something is off here. Again, I could do that differently. I'm offensive actions. I could just have my own offensive actions checkout. Like, there are legitimate reasons for that, especially if I make bigger changes to the checkout action. Datadog, for example, does that a whole lot. For their releases, they have their own like release helper GitHub Actions, and potentially no one questions that. I would hope we don't need to. But yeah, you can also maybe hide better in plain sight. But yeah, I just like the cheesiness of this. And then you see the job run logs. When your runner is actually set up, it will tell you the commit hash of the thing it checked out. And so we have that right here, and that is, of course, perfect. But where is this going to lead us? It's going to lead us to a 404. Why? Because right after using this, I just deleted my repository, and it's not connected to anything. Like, I just copied code. I didn't fork it or anything. And what did I do after that? I went ahead and forked Actions checkout into Acklon's checkout, tagged it with v5, and then afterwards didn't touch it at all. So if a defender who doesn't know about this trick goes in and looks at Acklon's checkout v5, he will see perfectly normal code that I just forked. He might think about, why is this guy forking it? But that's the end of it. But there is a really juicy alternative, and I love it. And it shouldn't be here, but I wanted to show it to you anyways. This is a best practice change, isn't it? Like, normally you tag to a version. That's actually what the README of GitHub of Actions checkout tells you. Take the version. But we can tag it to a commit. That's pretty good, isn't it? Anybody here who has an idea what might be the malicious thing behind that? 1, 2? OK, there are some arms going up. Cool. Perfect. Thank you. Because this is an orphaned commit. I checked out Actions. I forked Actions checkout into a repository of mine. I could have used any username. Then I did a malicious release or a malicious commit to that and completely purged my username and everything from GitHub. But this commit still exists, and the commit hash is in the network of the forks of Actions checkout, and you can still reach it via Actions checkout. So if I hadn't deleted my repository, you could go to it from github.com, my username, my repository name commit hash, but you can also reach it from github.com/actions/checkout. Same commit hash. So pretty good. You see this warning in the GUI, like this commit does not belong to any branches of this repository and might be a fork. But what does that really mean? Like, if you don't really think about it, you're kind of like, yeah, cool, so what? Some quirk, I guess. And you can't get this over the API, or at least I was not smart enough to figure it out. I asked like 3 different other AI tools. I Googled my ass off. If anybody of you has an idea how to figure that out via the API without doing crazy kung fu, please let me know. Because this is potentially something we should know. How to protect against that? Ask maintainers to use immutable actions publishing. This is, again, a new GitHub feature. I think it's not in preview yet, but it's coming in the next quarter. So keep your eyes peeled for that. What's going to happen here is if you have an action, you can actually publish this and then not change it again. Because right now, when you use an action, it's basically just doing a checkout from this repository. And as you can see, we can meddle with that quite a bit. So let's go to the attack number 3, using a hidden self-hosted runner. We have our source code, and we're also going to touch the build stage here. I'm a little bit sad. There was an attack that was amazing, and I loved it. Someone here last year at Forward CloudSec told me about this attack, and it was really cool, and then it stopped working about half a year ago. But thank you so much for telling me, because this also kind of inspired me looking into it, and I found something that could maybe replace it a little bit. Who spots the problem here? One hand? Two hands? Two ideas? Okay, I'm not going to ask you. 3 hands. I just wanted to get a feel for it, because I wouldn't spot it, obviously, or honestly, but GitHub does spot it. That is what we call a homoglyph attack. Again, it's one of my nice little, hey, I'm a red team, I have this trick here. It used to be Ubuntu-latest, and now it's Ubuntu n-latest, because the n- and the hyphen are very close to each other, and they're normally even displayed the same, but the bytecode is different. So yeah, you can definitely see that, but only if you start looking for it. So sorry, what does that do? I have a self-hosted runner, and if I tag my self-hosted runner with Ubuntu n-latest, and I call here for runs on Ubuntu n-latest, of course, GitHub, as it should, uses my self-hosted runner to run this job. And on a self-hosted runner, I'm root. I can do whatever I want, and so I can meddle with any release that I want. And that's exactly what we see here. This was tampered on a self-hosted runner, again, for an immutable release. You leave quite a bit of traces here, honestly. Let's look at the indicators of compromise. You leave quite a few of traces. You will see that, for example, in the run logs. It's very obvious in the run logs, but you can just delete them. And if you just delete them, they return a 404 if you try to get them over the API, and that could also be a quirk somewhere. Just deleting log is maybe not the worst indicator of compromise. At least you definitely can't tell what happened. And I really dove in deep again, and I found out for the last half year, this was a way of detecting it. If the runner group ID for the run that you're looking at is 0, it's a GitHub hosted runner. If it's not 0, it's not a GitHub hosted runner. All the other things here, like the runner name and so on, you can actually tamper again with other homoglyphs attacks. But this one line is the very crucial line here, but you need to look at it. How do you protect against it? You ask the maintainer why on earth they're not using GitHub hosted runners. I know there are reasons to do that, but GitHub offers these for free for open source, so probably people should be using them. And if they are not, you should really inquire why they are not doing that, because anything that comes out of a self-hosted runner might be, again, anything. You don't need to do any sus checking of everything that came before. Learnings. Attackers do leave traces. I have like 5.5 attacks if you look at the repository. For every single one, we did find traces. You can meddle with a lot of them, but for all of them, you in the end will find something. But you need to automate your detection. Like if you're already doing automated SAST checking before like the pipeline for the application source code, and you also use something like Step Security's Harden Runner to see what's running in your pipeline, that's also really cool, because then you will potentially catch something that's going on. But maybe you want to catch it before it actually makes it into your pipeline. So if you're already investing the money, you should look at that, automate it. Help the maintainers. Maybe the maintainers don't know about these immutability thingies yet, or they just didn't have the time to implement them, to look at them. Help them out. You're consuming something off of them that they normally offer for free. So yeah, why not get involved? And that's also really building for the future, because at the point where they are kind of like all of a sudden compromised, it's very weird if all the releases after that are not immutable anymore. So that definitely will help you and them. GitHub is helping you, because we definitely see that they are pushing for immutability, they're pushing for immutable releases, immutable tags, immutable action releases. So there is a great amount of stuff coming out there if you look at what they have open there. So yeah, thank you, I guess, GitHub for that. That's pretty cool. And last point, be prepared. I used to be a penetration tester. As the penetration tester, this is the stage where I would have sold you like an assessment. I'm not going to do that today, but maybe sit down. You will get breached at some point by an attack like this. On your personal machine, on your developer's machine, in your CI/CD system somewhere. It might be a big breach, it might be a small breach. Be prepared. Think about, hey, how do we rotate our biggest secrets? Like in which order should we do that? Sit down, do it now, because in 2 weeks you might be very sad that you didn't. with that, thank you so much. Thank you so much for attending. Thank you so much for Forward CloudSec to putting this amazing, amazing conference into living. And thank you so much, Christoph, for helping me build this into what it is now. And yeah, now go ahead and clone this repository. Thank you.
Awesome, excellent talk. Question from me, just to kick things off. So some of the recommendations you had on what people can do were more, as a consumer, you have, maybe 1 or 2 producers that you can support and help out. But a lot of organizations will have, hundreds, thousands, maybe even more dependencies. What kind of actions can they take to at least try to help mitigate some of that risk or prioritize targets or anything like that?
Honestly, I regret to say that I don't know. I really don't have a good answer for you. I just found out, if you start digging in deep, you know that it's everywhere. There is a great tool for checking GitHub Action pipelines. It's called Poutine, for a reason, because a poutine is a very messy dish. And yeah, this is super messy. So I'm very sorry I don't have that. I personally, if I were tasked that right now and my boss told me you do this for the next half year, I would probably try to find out which are my most important pipelines. And then I would see which are the first-party dependencies that we pull into these pipelines. And that's what I would start with. But again, it's like you look at one thing, at a seed, and all of a sudden it's a tree.
Awesome. I think we had a...
Hi, thanks for showing us all the ways that we can get it wrong. But it's hard to write a good GitHub pipeline. It's a whole other programming language we need to learn. Is there some sort of secure default solution that you could point to or recommend to help us not fall into a lot of these traps?
There is not a solution that I can point you at, but I can definitely tell you, learn how to write these pipelines, because we're talking about 2 things. You're talking, if I got you right, about the pipelines you write in your own repositories. GitHub has great courses on that. Actually, you can even get a little certification and everything, but that's great because there is content out there. And there are tools that will help you audit them. That's the stuff that penetration testers usually do when they start out. So I highly recommend do that yourselves. You will find links to these in my repository again. There is a whole section on prior research, and I highlight the 2 tools I really like the most here. I hope that's a good starting point.
Cool. Any other questions? Oh, yep.
Hi, I had a question about, I suppose, the homoglyph attack that you did. So I know that by default, on the visual diff tool for GitHub, I think there was a post by the maintainer for curl about this, where it essentially highlights only the character that was changed, and I guess the entire line. Did you try that same thing for, I guess, where you said actlons instead of actions? Was that possible to put a Cyrillic character or a homoglyph attack inside of there?
No, it is not. I actually, that's the first thing I tried. When I found that works, I was like, cool, which other namespaces can I take over? And I didn't look too deeply into that, so maybe that's a good lead to go after. But what I did, I just used the GitHub GUI to register a new username, and using an n- instead of a hyphen. And the GUI was very clear about, hey, only character, A to C, basically, numbers and hyphens are allowed and nothing else. I haven't checked the API. Maybe it's worth bombarding that API. I could definitely, they wouldn't allow me set up a runner group name, GitHub Action Runners, because it was GitHub space action space runners, and they were like, this group already exists, so I substituted the space with a non-breaking space, and it worked just fine. The only problem was I didn't get the runner group ID of 0, and so it was kind of futile to do it, or to show it off here on stage. It's in the repository, but that's definitely something I would go hunting for next. Yeah,
One more from the Slack. Are there ways we could look for malicious actions without having to inspect every pipeline? Does attestation help?
No. Thank you for the question. Not as far as I could figure it out. It kind of depends. There are 2 features. You get standard attestation that is basically built into immutable releases. If you have an immutable release, you get the attestation right away. You can see that if you go into my repository. I'm not connected to the internet right now, but if you go into the releases section, you see that there. Wait, maybe it's visible in one of the slides. Here, you see the release attestation at the bottom. So we have original TXT, the source code as a zip and gzip, and then the release attestation. This release attestation just attests to that this release is what it is. And so if I download this tampered with file and I run the attestation tool, of course it's going to be like, yeah, absolutely, that's the right file. Another thing is when you run on a self-hosted runner and you have that, they have another feature, I sadly forgot the name right now, where you can, like the build provenance feature, that's it. If you use the build provenance feature and someone is using a self-hosted runner, you will find the field self-hosted in the JSON of the build provenance, like buried deeply. But I've rarely seen that in use, so I didn't include it here.
Awesome. We'll do one last question.
I mean, you started with the fact that you're not going to hack into a repository, so you are a malicious maintainer. I guess the easiest way to do this would be to just release a new version that is malicious, and it will even raise less suspicion than tampering with the pipeline. Do you have any recommendations of how, or like?
I'm sorry, I'm going to repeat the question. I'm not.
So you started with this, okay, I am already a malicious maintainer,
yeah.
So we don't hack into a repository. So we might not do all that and just release a new version.
I could just release a new version, but the idea is if I just release a new version that is malicious and I put my maliciousness into the application source code, then it's out in the open. And I've seen companies that actually test like the repositories they consume and they look at that with SAST tooling. And so this would potentially get spotted. And so I would personally always try to hide it in the pipeline because that's right now not where people look. In 2 years, hopefully that's really different. That's one of the reasons why I give this presentation and keep not shutting up about it, because that has to change.
Awesome. Thank you, Ben.
Thank you guys so much. Or girls, guys, everybody. Thank you.